So one of the things you're going to have in your back pocket when you are evaluating integrals is just a knowledge of the antiderivatives of a lot of common functions. So some of these common functions are actually listed in this table. And I'm not going to spend time in this video to go through the antiderivatives of some of these functions. Rather, I'm going to leave that as an exercise for you. And I'll simply do another example. But before I do that, I want to talk about the idea of indefinite integrals. Okay, so we evaluated definite integrals, where we definitely got an answer. I think in one video we got the answer to be -25/6. In another video we actually got some numerical value like 14 or 2 or whatever it is. But indefinite integrals, you don't necessarily come up with a value. What you do is you'll see that in this notation you don't actually have the limits. So you don't know what to substitute into the antiderivatives. And so that's okay, because it's actually easier then. All you do is you come up with the antiderivative. Okay, so let's put this to the test here. Find the indefinite integral. So notice again, there's no limits. So the best we can do is simply come up with the antiderivative. So what we'll do here is the antiderivative of 3x squared is simply x cubed. The antiderivative of sec tan. What do you seek? Oh, I seek a tan. Okay, so then I guess it would be sec x is the antiderivative. And then now the thing is you need to add that constant there, right? Because that constant, the derivative of constant is 0. So really there are an infinite number of antiderivatives of this function. Because it's just going to be x cubed minus sec x plus some constant. It could be +1, +5, -2. Doesn't matter, because that constant, the derivative of that constant will be 0. Okay, so in part B, we have another indefinite integral. Now, with this one, there's a couple of things that you can do here. So I'm going to show you two possibilities. Okay, so one thing is you might kind of recognize 2 sine cos x as, let's see if we can do it this way, as sine 2x. Okay, so in your previous trigonometry studies, you might have learned the double angle identity sine 2x is really equal to 2 sine x cos x. So really, this is an equivalent indefinite integral. So now when you consider this, what you might want to say is, well, perhaps the antiderivative of sine 2x would be negative cos 2x. Okay, so because we know that the derivative of cosine x is negative sine x, so the antiderivative of sine 2x would be negative cos 2x. But the problem is that if I were to test this out and evaluate the derivative of negative cos 2x, so if I just do quickly here d dx negative cos 2x, I don't think I quite get sine 2x. What I get, let me be more obvious here. What I get is, yes, sine 2x, but by chain rule, I would also get a 2 out front, which this one doesn't have a 2. So I guess the best thing I can do is put a half in front there, right? So if I had a half in front, then, if I had a half in front here, then suddenly the half and the 2 would cancel each other out, and I'd still be left with a negative. Okay. So there it is. Oh, and don't forget the plus c as per usual. Okay, so there's one way of doing it. Now the other thing that we can do, if I can just move this to the side, oh, I guess I don't want to do that. If I could just move this to the side, one moment here. Okay, so we can do this as well, where we look at the 2 sine cos x and we think to ourselves, maybe it's we can do this. And this would be more of an inspection method. So I'll put an or there. Or it could be sine squared. What if it was sine squared x plus c? Right now, I just came up with that. I didn't really show any work for it, but I'm just thinking I recognize cos x as a derivative of sine x. But now how did I get that 2 there? Now I'm thinking power rule. Right? The power rule derivative says, hey, if you've got something that is a term that is squared, you would bring that exponent down. So let me just test this out over here. So the derivative with respect to x of sine squared x. Okay, wouldn't that be the 2 comes down, so power rule first, so 2 sine x to the 1, and then chain rule would be multiplied by the derivative of sine x, which is cos x. Right? So that would work as well. So it's quite interesting that for a given function here, we can actually come up with 2 different antiderivatives.